All right, guys, here are some of the additional examples that I have for you for finding the rational roots, real and rational roots for your polynomials when you can't factor them nicely. Remember, what you want to do first is factor it, check to see if there's a GCF, which there isn't here. Since I have 5 terms, factoring by grouping can get a little messy. So I'm just going to go ahead and do my P and Q just so you can kind of get the hang of it. So we're talking about the coefficient here and the constant here at the end. This is your Q, and this is your P, and now we're going to find the factors of each one. So we have 1 and 6, 2 times 3, okay? And then each one is plus or minus. Okay, here we have P, the factors of 10 are 1 times 10 and 2 times 5. Okay, so plus and minus on each one. So what we're going to do is we are going to divide all of the factors on the right by all the factors on the left. And so there's going to actually be a ton of combinations here. So I have plus or minus 1 over plus or minus 1 over plus or minus 2 over plus or minus 3 over plus or minus 6. Okay, and then I have to do it again for all of these. And this is why you want to make sure that you try to factor these as much as you can before you do this, because this is very time consuming. Plus or minus 3, and then some of these will double up, and I'll show you what I mean by that in just a minute. Oh man, what am I doing here? Plus or minus 6, okay. And then plus or minus 5 over here, over plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, and then lastly plus or minus 10. Now if you had like 15 factors over here, this would take such a long time. But I'm going to show you kind of how to manage this. So I'm going to go ahead and simplify any of these that I can. Okay, so this one's going to simplify to just 1. This one's also going to be 1. And that's it. Okay, so I have plus or minus 1 out here for both of these. This one is plus or minus 2. I think I will also have a plus or minus 2 right here. Okay, so those are going to simplify there. Do I have any whole numbers? Okay, right here I'll have plus or minus 10 and plus or minus 5. And then the rest are going to be fractions. When I mean that some of them are going to double up, I mean like this 2 over 6 actually reduces to 1 over 3, which we have right here. Okay, so all of these other ones are roots. This 10 over 6 is going to simplify to 5 over 2, which we actually have right there. And that's just what I mean by doubling up. So all the other roots are, you know, plus or minus 1 over 2, plus or minus 1 over 3. I'm just listing them again so you can kind of see what's going on. Plus or minus 2 over 3, plus or minus, that one canceled there. 5 over 2, plus or minus 5 over 3, plus or minus 5 over 6, and these other ones over here. This one canceled, so we're left with plus or minus 10 over 3. So all of these are all of the possible roots for this polynomial. However, we only want the real roots. So to make it kind of easier, I'm always just like to start with these because it's a little easier than working with the fractions. From here, we're going to check them with our polynomials. Once we find one root, we can kind of factor it out and see, you know, if whatever our remainder is, or what our other factor is. We could, you know, it's usually a little bit easier to factor. So I'm just going to start with 1. We're going to do our synthetic division. Remember, the numbers that we're using for this are these original coefficients. So 6, negative 43, 66, negative 3, and negative 10. So we're going to start with 1 here. Bring the 6 down. 6. 6, that's going to give you negative 37. That's negative 37. That's going to give you positive 29. When you multiply that, you get positive 29 here, which is going to give you positive 26. 26 here is going to give you a remainder, which is no bueno. So now we try negative 1. Negative 1 times 6 is negative 6. That's going to give you negative 49. That's going to give you positive 49. I'm going to give you 17 here, which is going to give you negative 17, negative 20, positive 20, which is a remainder. So 1 is out. So now we're going to try 2. Same coefficients. 6, negative 43, 66, negative 3, negative 10. Bring the 6 down. 12. Negative 43 plus 12. That's going to give you negative 31. Times 2 is going to give you 62, negative 62 over here, which is going to give you a positive 4. 2 times 4 is 8. Minus 3 is 5. Look at how nice. Okay, 5 times 2 is 10. We get a remainder of 0. So now we're happy. We can kind of chill. Okay, so this is going to be your first factor, x minus 2. Remember that we changed the sign when we're up here. So that's what that's going to be. And this comes down one exponent up here. So we started at x to the 4th. This is going to be 6x cubed minus 31x squared plus 4x plus 5. This is still no bueno. We want to try to factor it out as much as possible. So let's look to see if we can do grouping here. No, because nothing's going to factor from 31. So now we're going to do the same thing again. We're going to use these numbers over here to see if we can find another factor using this new coefficient over here, or this new part. So we have 6, negative 31, 4, and 5. And we need to pick another constant. So we know for sure this is one of our factors. And we're going to use one of these. So we can start with negative 2 if we want to, or we can choose from one of these other ones. Let's try negative 2 up here. Okay, so if this was negative 2, it would be 2 times, I'll write it again, okay? We tried 2, so now we're going to try negative 2. So it's going to be negative 12, which is going to give you negative 43, which is going to give you positive 86, which is going to give us a remainder. Okay, so that's going to be, 90 times 2, 180, okay? So the 2 didn't work out. So we're going to try another one. So let's go with, I'm going to try 5 because it's smaller. And it really doesn't matter how you choose which ones you want to go through. So 6, negative 31, 4, and 5. 6, 30, negative 1, negative 5, negative 1, negative 5. Look at that. Okay, so it works out nice. So we have this factor over here, which we use. So we have x minus 2. We have this new factor, x minus 5. Change the sign. And then whatever's left over. So 6x squared, because we're 1 less, minus x minus 1. This is still not factored, okay? Let's see if we can do our a times c over here. So we're looking for the factors of 6 times negative 1. That equal negative 1, which is going to be negative 6. Nope. Negative 3 times positive 2. All right, so this is a ton of work, guys. Look at this. X minus 2 here. X minus 5 here. I'm going to use bottoms up. X minus 3 over 6. X plus 2 over 6. Remember, it's always the factor over your value for a. X minus 2. X minus 5. This is going to simplify to 1 over 2, and this simplifies to 1 over 3. So bottoms up, 2 to the front, 2x minus 1, 3x plus 1. Look at that big mess. Okay, so we have finally factored it. We're still not done. We have to solve each one for x, okay, which isn't going to be too extremely difficult. So for this one, we're going to get x is equal to 2, x is equal to positive 5, x is equal to 1/2, plus 1 divided by 2, x is equal to negative 1/3, okay? Minus 1 divided by 3. These are all of our solutions, okay? So if you wanted to graph them, okay, you know that you would have a root at positive 2, you would have a root at positive 5, you would have a root at 1/2, and one at 1/3, okay? So you would have something that would start up here and, you know, look something like that maybe, okay? So that's what we're doing. Isn't that fun? That took all of 10 minutes to go through that. Okay, so I have one more example and some more practice problems if you want to go through them. I'll try to get through this quickly. Hopefully it won't take as long as that last one. So if we look at this, there's 4 terms. We can try grouping here, which actually might work out. Okay, so if I split this up into 2 pieces, I can take out an x squared over here, which is going to leave me with x plus 2. I can factor out a 9 here, which is going to leave me with x plus 2. That was easy. So we have x plus 2 times x squared plus 9. This is not factored, so we need to do that if you want to do your table. We're looking for the factors of 1 times 9. That's summed to 0, which is 3 times negative 3. X plus 2, x plus 3 over 1 times x minus 3 over 1, which are going to simplify nicely, plus 3, x minus 3, okay? Set each one equal to 0. And then solve each one. So minus 2, minus 3, plus 3. X equals negative 2, x equals negative 3, x equals positive 3. These are all of your solutions. Okay, we have something to the 3rd degree, or polynomials to the 3rd degree. So we know we have a root at negative 2, at negative 3, and at positive 3. Okay, so it's going to look something, you know, like that more or less. That's it for this one. That was tough. It's a lot of work, and it takes a lot of time and a lot of diligence on your part to do all of this fun checking over here. There's another practice problem that I have for you right here. If you want to, you can always graph it, guys, to check for your solutions. If you figure this out, I'll give you extra credit in class. So just bring it in and make sure you show me all the work. So if you bring it in and you give me the solutions and you don't have something that looks like this, I know that you didn't do it, okay? So you got to work for it, guys. If you have any questions, which I'm sure you will, come see me, talk to me. I'll also go over it a little bit more in class. Other than that, you know how to get a hold of me. Have a good night.